All right, 4-7A. This is congruence in overlapping triangles. Okay, so I'm not teaching you a new like SSS, SAS, HL, CPCTC. I'm not teaching a new one of those today. Today is just taking all that information and applying it to two triangles that instead of being two triangles like this, it's two triangles like this, where they overlap each other in some way, shape, or form. What are they doing out there? Okay. But here's the beautiful thing about this lesson. Every single proof has the reflexive property in it because there's something overlapping, so they're sharing either a side or they're sharing an angle. Okay, so when you're doing overlapping triangles, look for reflexive. I all but guarantee that is not the word reflexive. That it will be in there somewhere. Okay, look for the reflexive property. Basically what you're going to be doing is using a pair of triangles to prove some other pair of triangles congruent, or using a pair of triangles but separating them first to prove that they are congruent or something about them is congruent. Okay, so on your test, I'll tell you right now, you're going to have a picture where the triangles overlap, and I give you a little box, and I say separate and redraw them. Okay, you need to draw them as two separate triangles, even if you don't need it for you to figure out the proof. It is points on your test. You have to do it for me. Okay, so you have to separate and redraw them and mark up what you know and label them how you know they're labeled for points on your test. Okay, so just keep that in mind. That is not optional. When I say separate and redraw, that means you have to do it. Okay, I highly recommend you do it in the homework because it just helps you to see what you need to see. Okay, then you can mark up what you know a little better. Yeah, Kenny.
And this is only for 4.7?
4-7, yeah. You're separating them, yeah. Okay, so here's what you're going to be doing. This one's not a proof yet. It's just figuring out where the reflexive part is. Let's say we have this picture. This is X, Y, W, and Z, okay? I'm looking at triangle WXZ and triangle XWY, okay? Because there's a lot of triangles in this picture, right? There's like 3 that you can see just as individual triangles, but then there's also the bigger overlapping triangles where there's those 2 triangles. Those are the ones we're looking at. So WXZ, that's this triangle, okay? So that's this guy. But then there's also XWY. XWY is the blue triangle, right? So we have the blue triangle and we have the red triangle that are overlapping each other. What I'm looking for is in those 2 triangles, what's reflexive? What is the shared side or the shared angle? XW, right? Okay, now the reason I say separate and redraw them for the proof is you're going to have a lot more things to mark up, right? On these ones, it's not so imperative that you separate them, but we could. You have XWZ, and you have, WXY. You can see in that both of them have the segment XW. That means that is the thing that's reflexive. So XW is your reflexive segment. Okay. What about in this setup? Excuse me. Thank you. Okay, so now I have triangle ABE, ADE, and triangle CFE. Can you tell me in those 2 triangles, ADE, and CFE, what do they share? What is the common side or angle? Angle E, right? You have this triangle here, and you have this triangle here. The only thing that's identical about them is this angle, angle E. So the reflexive property here would be angle E is congruent to angle E. Okay, so that's what you need to look for in these proofs. And we're gonna do 2 proofs of this. And if you need some extra help beyond that, I can come around and help you with your homework. But this is kind of the general setup of these overlapping ones. So huge importance. Separate, redraw, and mark up. Okay, you're gonna do this on each one of these proofs. So here is our first proof. Let's say we are given that RT is congruent to US, angle URS, and angle TSR are right angles. And we ask you to prove angle T is congruent to angle U. Okay, and I'm gonna ask you a couple questions before I even draw the picture, because I don't want you to even see the picture. I want you to see that there's things you can figure out without even seeing a picture, okay? First thing I wanna know is, do you have a guess what kind of triangle congruence you'll get in this problem? SSS, SAS, ASA, which one are you gonna get? HL. Why do you think HL? Okay, because they tell you you have right angles, right? So there's a really good shot right now that you're trying to get to HL. So keep that in mind. That's something to look for, okay? Second thing is, do you have a guess what your last step of this proof will be? If I'm proving an angle congruent to an angle, what typically is your last step? Hewlett-Packard? CPCTC, right? If we're not proving triangles congruent, but we're proving parts of triangles congruent, you're usually ending on CPCTC. So before you even start a proof, look for that stuff. Look for, what do I think this is gonna end up being, and what things am I potentially gonna see in this proof?
It goes HL and then CPCTC.
It would go HL and then you can do CPCTC, yeah. Okay, so chances are those are the last 2 steps of your proof. It's not a guarantee, but those are the likely answers, okay? Okay, so here's your picture. You have this is R, S, T, and U, okay? So they're talking about angle T and angle U. That's what we're trying to prove congruent, okay? So those have to be angles in our triangles that we're talking about. There's 2 sets of triangles that could have angle U as part of them. Do you see what 2 triangles those could be? 2 sets of triangles? They might be talking about this triangle with this triangle, right? But are those overlapping? No. So chances are it's not those ones right now. Instead, they also told us that these angles are right angles. Well, that's this angle here with this angle here. So it looks like the 2 triangles you're going to be using to include angle T and the right angle would be that one and this green one. Right? So what you're going to do is you're going to separate them and redraw. So I'm going to draw angle URS. And angle RST, triangle, sorry. Okay, so think about what they told us. RT is congruent to US. So RT congruent to US. And they told us URS and TSR are right angles. So right angle here, right angle there. What did I tell you to always look for in overlapping triangles? A common side, right? Or a common angle. What do you have in common on this one? RS. So we can say that RS is congruent to RS by what? Reflexive. Okay, so step one is your given. Step two, I would say that RS is congruent to RS by the reflexive property. Okay, so think about how we get to HL, because we said this one looks like it's probably going to be HL. We need to know two congruent hypotenuses. Do we know that? Yes. We need to know two congruent legs. Do we know that? Yes. We need to know we have right triangles. Do we know that? Have we proved that? We haven't proved it yet, right? So last thing you need to say before we get to the HL factor is triangle RSU and triangle SRT are right triangles. Why do we know that? Definition of a right triangle. Okay, so what can I say next? We've done our three parts, so now we can say HL, right? We can say triangle RSU is congruent to triangle SRT by HL. What's my next step? T congruent to U, right? If we know the triangles are congruent, we know the parts of them are congruent. So angle T has to be congruent to angle U by what? CPCTC, okay? And this is what I'm telling you right now. On your test, I give you a box, and I say separate, redraw, label. This is what I need. I need you to put the letters in, okay? All those letters have to be in there, and the markings. You need to mark what you know in those pictures. If you do that, those should be easy points, okay? But don't not do it. For some reason, every year, people just skip that part. Okay? Questions on that? Okay, one more proof, and then I will let you try it out. Given that angle ZXW is congruent to angle YWX, and angle ZWX is congruent to angle YXW. That's a W. Can you see that? That's a W at the end. Sorry. We're going to prove that ZW is congruent to YX. Okay, here's your picture. Any guesses what your last step will be? CPCTC is a pretty good guess, right? Because you have segments congruent, parts of triangles congruent. So if this is Z, Y, X, and W. So you want to separate and redraw the triangles. Well, look at what they're telling you. Angle ZXW. So ZXW, that's this angle. Congruent to YWX, that's this angle. ZWX is this angle. Congruent to that angle. So the two triangles that you have would be this triangle here. Okay, so ZWX with YWX or YXW, if we're naming it the same way, here. So here's W, here's X, here's Y. Okay, so you want to mark up what they told you. Angle ZXW congruent to YWX and ZWX congruent to YXW. Okay, that's what we know so far. They're asking us to prove that ZW is congruent to YX. So we have to prove sides are congruent. What can you tell me in this proof? What do you always look for in overlapping triangles? Reflexive. Where do you see something that's reflexive? Segment WX. Okay, so you're looking for an angle or a segment that's identical. Well, this segment right here is this segment, and it's this segment, right? So we're going to say WX is congruent to WX by the reflexive property. Okay, so mark those congruent. What do you see now? ASA, right? You have angle, side angle on the top triangle, angle, side angle on the bottom triangle. So we're going to say triangle ZWX is congruent to triangle. So if it's ZWX, what triangle is it? YXW. By angle, side angle. What do we say next? CPCTC with ZW congruent to YX, right? What they asked you to prove by CPCTC. Okay, see the pattern? Reflexive shows up, and then once you have enough information, an ASA with a CPCTC or an SAS with a CPCTC or an HL with a CPCTC. So if you're proving parts of triangles congruent, two segments congruent, or two angles congruent, chances are you got CPCTC. Okay? Questions on that? All right.